experiment here. I made little tiny glaciers for us, okay? Because I heard that it might melt. So imagine, visualize this being a big old chunk of ice that's on our Earth. And what do you notice down here, Ari? What's in there? Rocks, sand, chunks of land. Do you guys think that's how a glacier would be on Earth? Yeah. It's not like ice is going to form and just sit there by itself. It starts melting and it sucks up things around it. So I'm going to give you a little tiny glacier. And I'm going to give you just a regular piece of ice. Okay? Think of this as maybe your iceberg. All right? Nothing in there. It's not on my land right now. If I could have two volunteers, one's going to bring around a glacier, one's going to bring around an ice cube, plain old ice cube. Robert, sir, and let's get a lady, Vicki. If I can have one more volunteer. Let's get Miguel. Okay? Here's how it's going to work. These three people are going to give you, in pairs, a cup, a glacier, and an ice cube. Okay? Does that make sense? All right. This is for you, ma'am. One for paired people. While you're waiting, guys, I want you to start checking out this picture right here of the Grand Canyon. See what you notice about it. Say what? Why do you say that? What's that? While you're waiting, I want your attention to the Grand Canyon picture. Think if we were to make a topographic map with this guy here. Do you think we need a lot of contour lines to show different heights? Araceli, I'm going to wait for your attention. You ready? Araceli, what do you notice about the heights of this Grand Canyon here? Is it all the same? Is it different? What do you think? Some are smaller, some are bigger. Nick, can you sit that down, please? Sure. All right. Do you guys think maybe some of the Grand Canyon was changed by some of these processes? Okay. Let's check it out. Let's see what's going to happen. It looks like there are some parts that are really huge, some parts that are cut in. Thanks. So we'll have to see what's going on with it. Yes, ma'am. We ran out. Oh, you need another? Is there any other group that still needs anything? You guys need them? We take this to Brian too. Do you guys just need the glacier? Yeah. Okay. All right. Here's what I'd like you to do. You have your cup, and we're going to pretend that this is, right now, upside down, a mountain. So if you can turn your cup upside down and make a mountain for me. All right. And with your partner, one partner is going to work with a glacier to decide who, doesn't matter. And one of you is going to work with a regular plain ice cube. Decide who. I know it's a little wet, don't clean it up, that's okay. Science can be messy. Vicki. You need a regular one? All right. Voices are off in. You need what? Voices off in 3, 2, 1, 0. The person who has the glacier, if you would please take that right now. Thank you. And I want you to put it on top of your mountain there, top of your hill. Just hold it up there. All right. There's glaciers along the land. And then I'm back here, so make sure to turn your attention this way. If I have my glacier on top of my mountain, I want you to pretend that it's sliding. And I want you to push it down your mountain. Okay, so right now, take your glacier and push it down your mountain. Did it fall down your mountain? Did you have it fall down your mountain? All right. Now, it will probably work this way, though, because the ice is going to form on top of the land, and the land's going to be on the bottom. So go ahead and have it slide down now. top with the land on the bottom since the ice is forming on top of the sand that's already there. So go ahead and drag it with the sandy side down.
The rocks are hollow.
That's okay. Your glacier's melted. Did you already drag it down? Where at? Alright. Can I drag it down once?
Yes.
Oops. All the cards. What do you notice happened? Okay. Got some cracks on there. Alright. And it's me at 3, 2, 1, 0. Right now, I want your idea is, when you drug your glacier down your mountain, what happened to it? Raise your hand, please. Viviana.
The cup got scratched.
Okay. So the cup was scratched. Anything else? Julie. The rocks are falling. I'm going to wait until I have faces up here. You guys ready? Okay. The rocks fell. Anything else? Now, the ice is starting to melt. Okay. One last idea. Eric. Okay. Here's what I'd like you to do now. Go ahead and move your glacier out of the way and take your regular ice cube. This is for the other partner now, making sure everyone's getting a shot here. Go ahead and drag your ice cube down the side of your mountain. Alright, I want to see something. I noticed a lot of people doing this because we had that glacier scratch it, so you guys are going down, trying really hard. Did it do anything? No. No. Alright, so raise your hand if you think it's okay for me to write down that the regular ice didn't do hardly anything. Did it change the surface? Only 3 people agree with that? Made some funny noises, okay? So maybe I'll say the ice makes noise, but it doesn't really affect the surface. So it makes noise, but no real change. Alright. Here's what I'd like you to do. Go ahead and open up that packet you have. On the back of that Grand Canyon page is a little worksheet, a lab page for you. And I'm going to wait till voices are off. If one partner would just quickly pick up those ice cubes, I see them melting all over your stuff, and put them inside your mountain, inside your cup, so they're out of your way. That's okay. The rocks fell out, that's okay. We'll get them removed. Alright. On this chart it says how weathering shapes topography. Weathering. We have some weather in here. Our ice starts to melt. Maybe the temperature got too hot for it. We're not a cooler. Your sandy ice cube, I want you to draw a picture on this cup of what happened to the cup when you drug the sandy